Okay, guys, so we're recording now. So I'm going to talk at this volume because otherwise this can be really loud. So if you want to be heard in the video that I'm going to share with you, as well as your classmates who are not here, then just make sure that you ask your question or talk loud enough. If I feel like you didn't talk loud enough, I'll just repeat your question. So the very first thing that we're going to do to graph y equals sine squared of alpha is I took the values between 0 and pi on the unit circle and just plugged them in onto my table. So now we're going to evaluate sine of alpha for each of these. So if I'm looking for sine on my unit circle, which value represents sine?
Y.
What?
Y.
The y value. Okay, so at pi over 6, what's the y value?
1/2.
Pi over 4?
2 over 2.
2 over 2.
Pi over 3?
Radical 3 over 2.
Pi over 2?
The next one should be 1, I believe.
2 pi over 3?
Radical
3 over 2.
Radical 3.
3 pi over 4?
Radical 2 over 2.
5 pi over 6?
1/2.
And pi? 0. Okay, so a value that I didn't put on there that's going to be really helpful on my graph is what's the value of sine at 0?
0.
0. So I can plot my first point at 0, 0. I'm just going to talk about that. So after this, after I've evaluated for all of my sine alpha, that's not what I wanted to graph, right? I wanted to graph sine squared. So I have to take all these values and square them. And so while you may be tempted to type this in your calculator, don't, because all the square roots are going to go away. So they're really not going to be so bad. What's 1/2 squared?
1/4.
1/4.
Radical 2 over 2 squared?
1/2.
Radical 3 over 2?
3/4.
1.
1.
1.
And then my values are repeating, right?
Yes.
So I'm going down 3/4, 1/2, 1/4, and 0 squared is 0. So looking at my graph and the way that I can graph this, the column all the way on the left, theta, is going to represent my x values on my x-axis. What's going to represent my y values?
Sine squared.
Sine squared, so this stuff. So my x-axis is labeled for me and it's counting by pi over 2. So let's go ahead and graph the stuff that's labeled on the x-axis and then we can fill in the pieces in between. My y-axis is not labeled. What's the highest value that I'm going to reach?
1.
1. So I'm going to call this top value 1, which makes this middle value 1/2. And then 1/4 and 3/4, which works really, really nicely for our output of the sine squared function. So the first thing that I'm going to be able to graph is at pi over 2. What's the value of sine squared at pi over 2?
1.
Okay. Then the next one that I have is pi. And at pi we have
0.
0. So this is not nearly enough to make my sine curve look like anything. So I can go to pi over 6. So if this is pi over 2, I can rewrite pi over 2 as, if I want 3 pieces, 3 pi over 6, which means that this first tick is pi over 6. So I saw that between 0 and pi over 2, there were 3 pieces or 3 ticks. So if I want to figure out the value of the first 2 ticks, I want to turn this third one into a 3. So I turned it into a 3 by multiplying the top and bottom by 3.
Whoa!
So at pi over 6, what is my output value?
1/4.
1/4. And at 2 pi over 6, I'm running out of space. 2 pi over 6 is equal to what?
1.
Pi over 3. So 2 pi over 6 equals pi over 3. So at pi over 3, what's my output?
3/4.
And then I can mirror this, so I've got 3/4 and 1/4. So now we only graphed the first curve of this sine squared function, so we need to figure out what's going to happen after this.
Can go under.
Am I going to go underneath my x-axis, do we think?
No, because that's
Yes,
negative.
indeed.
No, because it's negative, and why won't my function be negative?
Because there's no negative numbers.
There's no negative numbers in what I wrote initially, but what is it about sine squared? If that makes
Oh,
if
if
you
you
square
square
it,
something, it's never talked
Positive.
about.
Anytime I square a number, it becomes
Positive.
positive. So even though my sine alpha goes negative after this point, sine squared of alpha is going to be the same values but positive. So I'm going to repeat this pattern between pi and 2 pi.
Wait, you can just do that? Like, why don't you just stop and then, never mind.
Stop the wait.
So now this is sine, so it's going to be curvy. So I'm not just going to connect straight lines because then it won't look like a sine curve. So I'm going to go boop. So now what I want to do is use this graph to answer my problem. So I graphed y equals sine squared of alpha, but number 1 does not say y equals sine squared of alpha. It says 2. How do I get rid of that 2?
Divide by 2.
Divide by 2 on both sides. So I can rewrite this as sine squared alpha equals what? 1/2. So I am looking for the places on my graph where the y value is 1/2. So I'm going to draw a horizontal line that represents y equals 1/2. And these intersections are my solutions to this problem.
Do we actually calculate them or can we look?
We can look at the table we made because 1/2 is listed as an output. Where is 1/2 listed as my outputs? Pi over 4 and 3 pi over 4. So I know that my answers in these two locations, so this first point happens at pi over 4. My next point happens where? What's this one?
3 pi over 4.
3 pi over 4. What do you think the next one's going to be? I would bet that it's still going to be a fraction of 4. So if you take a look at the unit circle, the next time I hit a pi over 4 is at 5 pi over 4. And then what about the last one?
7 pi over 4.
Wait, how did you know that?
Based on the unit circle. So after I pass 3 pi over 4 and get to pi, the next time I get to a pi over 4 answer is 5 pi over 4. Based on the fact that these are equally spaced. So we have officially graphed to match our solutions of pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4.